Hello everyone and welcome to today's video on functions in Python. In this session, we'll explore what functions are and why they are so useful. Let's begin by understanding the definition and advantages of functions. A function is a reusable block of code designed to perform a specific task. The primary benefit of using functions is that they allow you to break down complex problems into smaller, more manageable tasks. This means that instead of writing one long complicated script, you can create several smaller functions, each responsible for a specific piece of logic. Now let's talk about the advantages of using functions. Readability. Functions help organize your code in a way that makes it easier to follow. When the logic of your program is divided into separate functions, each performing its own task, it's much clearer what each piece of code is meant to do. This clear separation improves understanding for anyone reading the code. Efficiency. Using functions can significantly reduce redundancy. Imagine having a piece of code that you need to run multiple times throughout your program. With functions, you write the code once and then you can call the function wherever it's needed. This not only makes your code shorter but can also improve performance in terms of speed and memory usage because you are not duplicating code unnecessarily. Reusability. Once a function is written, it's ready to be used repeatedly, either within the same program or even in different projects. This reusability reduces development time as you don't need to reinvent the wheel every time you need to perform a common task. Next, we move on to parameters and arguments. It's important to understand the difference between these two. Parameter is a variable in the function definition. Think of it as a placeholder for the value that will be provided when the function is called. For example, when you define a function like def my function abc, the names abc are parameters. They indicate what kind of inputs the function expects. An argument, on the other hand, is the actual value you pass into the function when you call it. So when you call my function 123, the values 1, 2, 3 are arguments. They are assigned to the parameters abc respectively. To put it simply, parameters exist during the definition of the function, while arguments are provided when the function is executed. Another example is a function called greet. When you define def greet name, name is a parameter waiting for input. And when you call the function with greet Alice, the string Alice is the argument that fills that parameter. Now let's look at a practical example involving conditional logic. Consider the following code snippet that checks whether a number is even or odd. Here the program checks if the number stored in the variable num is divisible by 2. Since 10 is even, it prints the number 10 is even. And if you provided something odd, it would print the corresponding number is odd message. We have already seen this before. We can encapsulate this logic in a function called even or odd, when the function takes a parameter named number. When you call even or odd 39, the value 39 is the argument and the function prints the number 39 is odd, and likewise for even. Finally, consider a slightly more complex function called cal. This function performs a calculation based on whether the input number is even or odd. If the number is even, it calculates the square. If it's odd, it calculates the cube. Here, when you call calc3, the function will cube 3 since 3 is odd. Later, when you call even or odd calc4 computes the square of 4 because 4 is even, returning 16. And then even or odd prints the number 16 is even. Now let's explore how to apply functions to lists and other iterables using different methods in Python. Let's start with a simple scenario. Imagine you have a list of numbers. Now if you try to apply our function, which we previously called calc, directly to the entire list, Python will raise an error. The error you see is a name error, indicating that the function calc is not defined for that input. This happens because the function was designed to work on a single number, not on a list of numbers. This example reminds us of the importance of ensuring that we are applying functions to the appropriate type of input. To solve this, one effective approach is to use list comprehension. With list comprehension, you iterate over each element in your list and apply the calc function to every individual number. This method processes each element one by one and then collects the results into a new list. When you do this, you end up with a list of outputs that correspond to the result of applying calc to each element. For example, the output shows that each number in the list has been transformed as expected. Small numbers remain small, while large numbers like 56 produce a much larger result. This approach is very concise and keeps your code readable and efficient. Another method to achieve the same result is by using Python's built-in map function. The map function takes two arguments, a function and an iterable. When you pass calc and your list of numbers to the map function, it applies the function to every element on the list. By converting the result of map into a list, you get the same output as with list comprehension. The map function processes every element in the list in the same function, and it is particularly useful when working with larger datasets. Next, we explore a different technique using NumPy library. First, you convert your list of numbers into a NumPy array. NumPy arrays are optimized for numerical computations and allow for vectorized operations, meaning they can perform the same operation on multiple elements at once. In this case, you use NumPy's vectorize function, which applies the calc function to each element of the array. The result is a new NumPy array containing the computed values. Finally, if needed, you can convert this NumPy array back into a standard Python list. This method demonstrates the power of NumPy for handling numerical data efficiently, especially when working with larger collections of numbers. Now we move on to a function that operates on an iterable in a different way. In our next example, we define a function that processes a list by iterating over it and determining whether each number is even or odd. The function creates an empty list and then checks each number in the input list. If the number is even, it appends the string even to the list. If it is odd, it appends odd. Once every element has been processed, the function returns a new list containing the labels even or odd. When you apply this function to our list of numbers, you get the result that clearly indicates which numbers are even and which are odd. But again, here you will encounter a type error if you provide a single value input instead of a list. This error can be handled like this. This function called iterate anything tries to convert the provided data into an iterator. If the data is indeed iterable, such as a list or even a string, the function proceeds to print each element one by one. However, if the input is not an iterable, a type error is raised and the function catches this error and prints a friendly message, not an iterable. Instead of this, we can also include some alternate functionality for single value inputs. This approach of error handling is crucial as it prevents your program from crashing when unexpected input is provided and instead gives you a clear message about the problem. Great. Now we'll be exploring some advanced topics related to function parameters, like args and quarks used to handle an arbitrary number of arguments. But before that, let's learn three methods of passing arguments to a function. Default arguments are values that are automatically assigned to a function's parameter if no argument is provided during the function call. Imagine you have a function that is designed to retrieve information about a person. This function might expect both a name and an occupation. However, if the occupation isn't provided when the function is called, you can set a default value, say unspecified, so that the function still has a value to work with. This means that when you call the function with just the person's name, it will automatically print the occupation is unspecified. The key takeaway here is that default arguments simplify function calls by allowing you to omit some arguments while still having meaningful values in place. Positional arguments are assigned to function parameters based solely on their position in the function call. This means that the first argument you pass is matched with the first parameter defined in the function, the second with the second, and so on. For example, if you have a function that describes a person by name and age, and you call it by providing a name first and then an age, the function will output that the person is that many years old. Order in which the arguments are passed is crucial here because it determines how the function interprets each value. Keyword arguments are passed with parameter names explicitly mentioned in the function call. This approach allows you to provide the arguments in any order because each element is linked to a specific parameter by name rather than by position. For instance, if you use a function that describes a person, you can specify the age and the name by their respective parameter names regardless of the order. The flexibility of keyword arguments not only makes the code more readable but also helps avoid mistakes when a function has many parameters. After that, we explore args, which stands for arbitrary positional arguments. When you include an asterisk before a parameter name in a function definition, it tells Python to collect any extra positional arguments into a tuple. This means that you don't need to know in advance how many arguments might be passed to the function. They will all be grouped together into a tuple, allowing you to iterate over them and perform operations like summing them up. This feature is especially useful when you want to write a function that can handle any number of inputs without explicitly defining each one. Following args, we come to quarks, which handles arbitrary keyword arguments. By using two asterisks before a parameter name, you enable your function to accept any number of keyword arguments. These keyword arguments are collected into a dictionary, where each key corresponds to the parameter name and each value is the associated argument. This mechanism is particularly handy when you need to pass a varying number of named parameters to a function. For example, you might write a function that displays information about a person, and you aren't sure in advance which specific details will be provided. With Quarks, the function can dynamically handle all those key value pairs, iterate over them, and process or display them as needed. That wraps up our complete journey through Python functions. We covered everything from basics like parameters, arguments, and advantages of using function to more advanced topics such as args and quarks. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Drop a comment if you have any questions or topics you would like us to cover next. Thanks for watching and happy coding.